Hi friends, a warm welcome to all. Today we are going to discuss some cells in the stomach and its secretions, and the cells were present in the duodenum and secretions, its hormones, and basically we can talk about the endocrinology of the stomach system. And the food gets into the through the esophagus. We have a sphincter here, and this is the cardiac part and the fundus part and the body and the antrum and the pylorus. We have the pyloric sphincter here and the rugae or the foldings in the stomach. When we take the histology of the stomach, we can see four layer: mucosa, submucosa, muscular, and the serosa. And here the mucosals present. Mucosals were present in the fundus. You can see also the chief cells or oxidant cells in the fundus, and the parietal cells were present in the body predominantly. In the antrum, you can see two cells, just the G cells and the D cells. I will tell you the functions of the cells. And you can see in the duodenum the S cells, the CCK secreting cells, and the GAP secreting cells. It means gastric inhibiting peptide hormone. And the ECL cells were also present in the fundus. It is also known as endochromatin cells, like cells. Okay, vagus, it's a parasympathetic nerve system. It's a part of parasympathetic nerve system, and it releases acetylcholine. It gives the positive feedback on ECL, and it secretes the histamine. And vagus also give positive feedback to G cell. It secretes the gastrin. And vagus gives positive feedback to parietal cells and helps in the releasing of HCl. It helps in the acidic condition of the stomach. And both the histamine and the gastrin gives a positive feedback for parietal cell, and eventually it leads to the secretion of HCl. And you can see the HCl is secreted in the lumen and the chief cells. What is the function? It releases the pepsinogen. The function of the pepsinogen is a degradation of protein into peptides, and the activation of pepsinogen into pepsin by HCl. And also it helps in the conversion of the Fe3A plus to Fe2 plus, or the HCl is also helps in the calcium absorption in the duodenum. And the functions of gastric HCl include it maintain the optimal pH 1.2 to 1.5 for digestion of protein by pepsin. It converts inactive pepsinogen into active pepsin. It stimulates duodenum to liberate secretin. It helps in the absorption of iron by converting ferric hydroxide of the food into ferrous form by reduction. It denatures food protein, making them more readily digestible. It has a germicidal effect on microorganisms and hence prevents the growth of microorganisms in the stomach. It has bacteriolytic action. It kills some of the bacteria entering into the stomach along with food substance. It provides acid medium for the action of enzymes. It activates release of other hormones like secretin and cholecystokin in small intestine. In the body, we can see the parietal cell at it release HCl. Also, it releases the intrinsic factor, which helps in the absorption of vitamin B12, vitamin B12. And in antrum, we can see the G cell. The G cell secretes the gastrin and it releases into the blood vessel. So it's a hormone, right? And it has a positive feedback on the parietal cell and it leads to the production of the HCl. And the gastrin has a positive feedback on the chief cells. I already said that chief cells produce pepsinogen, and it has a positive feedback on gastric motility and its secretions. Gastric a positive feedback for gastrin have a positive feedback on gastric emptying. The duodenum has secretin or S cells. Secretin helps inhibition of the gastrin and inhibition on the G cell, and it has positive feedback on pancreas duct, and it leads to the production of bicarbonate secretion. And also it has a positive feedback on liver, and it leads to the secretion of the bicarbonate ion. And the CCK CCK, it has the positive feedback on the secretin, and CCK has a positive feedback on pancreas. It leads to it has an effects on the pancreatic acidity, and it leads to the production of the enzymes, and it has a negative feedback on the sphincter of Oddi. It leads to the relaxation of sphincter of Oddi, and it has an effect on the gallbladder gallbladder, and it helps in the contraction of the gallbladder. CCK have the positive feedback or the contraction of the gallbladder, and CCK is activated by the fat content, and the amino acid content is coming from the stomach and it entering into the duodenum. And GIP is gastric inhibitory peptide, and it has a negative effect on parietal cells and the G cells. It has that negative effect on the gastric motility and its secretion. We can say it's by in a simple way. Okay, parietal cell, it is positive feedback. It gets positive feedback from gastrin, histamine or ACL, and it gets positive feedback from vagus, and the gastrin and the histamine is get also positive feedback by vagus nerve, right? And parietal cell inhibited by CCK and GAP, and the gastrin is inhibited by high amount of HCl coming from the stomach into the duodenum and secreting, and GIP somatostatin or D cells. I am drawing D cells here. It has a negative feedback on the G cells, and gastrin is positively feedbacked by digestive products, caffeine, alcohol, and distension, nerve stimulation, and increased Solinger-Ellison syndrome. We can see gastrinoma in this condition. In this condition, gastrin also produced very highly in this syndrome. And the CCK stimulus, it has two functions. It have stimulant function and the inhibition function. It stimulates pancreatic and acidity and leads to the enzyme secretion, and it acts on the gallbladder and leads to the contraction of the gallbladder. It has positive feedback on the secretin. CCK inhibits reabsorption of sphincter and parietal HCl secretion and the gastric emptying. And the gastric inhibiting peptide, it inhibits parietal cell secretion, and also it inhibits gastric cell G cell gastrin secretion. And you can see a table here. This is a simple one: hormone source, stimulus, stomach modulating secretion, pancreas and gallbladder. Secreting source is SL lining duodenum. Stimulus is from acid entering into the duodenum, and the stomach motility and its secretion, it inhibits the stomach motility and secretion. In pancreas, it stimulates fluid secretion of bicarbonate ions. It has no function in gallbladder. And CCK, the source is cell lining duodenum. It gets stimulated by fats and amino acids entering into the duodenum, and it inhibits the emptying in the stomach region and stimulates enzyme secretion from pancreas, and it has the effect on gallbladder, the contraction of the gallbladder, and in sphincter of Oddi, it leads to the relaxation. Gastrin, the source of gastrin is G cells of stomach, and it gets stimulated by stomach distension, and gastrin, its source antrum and the duodenum also, and both are get stimulated by parasympathetic peptides and from stomach acid inhibits, and GAP and the gastrin has a stimulus effect on the motility and its secretion, and the GAP, the source is duodenum, and the stimulus, the fat amino acids and the stomach motility and secretion, it inhibits the stomach motility and in its secretion, and the GAP has effects on the pancreas that increases insulin and decreases the glucagon. Okay friends, I think this video is helpful for you, and if you have any doubt you can add on the comment section. Have a nice day. Bye.